Okay, it's about 1 minute till, but I'm going to go ahead and get started. We've got some stuff we need to cover today. Um, I want to spend more time going through some of the Python operators that we talked about last time and give you more detail because I kind of rushed through them. And I also then want to get into conditionals, if statements, um, if else, and if else, which are the three possible sets of conditionals in Python. And then I want to leave some time, I hope, at the end of lecture to talk about homework one. Homework one, as you recall, is due at midnight Wednesday. So you still have lots of time, although hopefully you're pretty much wrapping it up. I did shortly before class also put out homework two. So homework two is now available, and it's on the GitHub site. It is going to be due next next Monday night. I'm sorry, the 21st. Looking at my calendar, homework two is going to be due next Monday night, the 21st at midnight. So you've got plenty of time, but again, probably best to get started. Let's see. So let's move on and get started then. So operators, we talked about these a little bit. I want to go into some more detail. Operators are special symbols that perform defined operations on data and expressions and variables, what have you, in your Python program. We have four classes of them. Mathematical operators, which we mostly talked about last time, so I'm only going to talk a little bit about them today. Comparison and relational operators, those you've pretty much seen. Assignment operators, and Boolean, logical, or conditional operators. Okay. Now, I did talk last time about mathematical operators. Mathematical operators defined in Python are plus, the plus sign, which is addition, and it works exactly as you would expect. The minus sign, which is subtraction, works exactly as you'd expect for both integers and floats. Times is multiplication, works as you'd expect for both integers and floats. The single slash is floating point division, and we talked last time about how floating point division results in a floating point number. Now, you can do floating point division on either integers or floating points. You can have, I'm sorry, is someone trying to speak? Okay, I probably just couldn't hear anything. Oops, hang on. Okay. Okay. The double slash is integer division. Okay. Integer division, remember, is only valid on two integers officially and results in the quotient with the remainder thrown away. If you want the remainder, that's the modulus operator or the percent sign. Exponentiation, to take a number to a power, that's the double asterisks right next to each other. And I give a couple of examples here that we sort of talked about. Let me really quick bring up PyCharm. And oh yes, it would help if, in addition to sharing, to bringing up PyCharm, I actually shared it with you. Here we go. Now, okay, now we've got PyCharm I'll post this file later tonight. It's September 11th, coding.py. This will be code covered in class. And it's interesting, on September 14th, I'll fix the name later on. So again, floating point division, 7 divided by 3, we'll say x equals 7 divided by 3. In a Python console, when we run that, I've had a couple of questions from students, and let me say, if you're using Python and you just want to check the value of something, that's what I did here when I just said X. Just giving the name of a variable will print out whatever value is associated. If you want your program to actually print something out, then you need a print statement. So if we do this, you can see that X is 2.333 and so on. And again, by default, it's going to give you 16 decimal places. You can change that with format strings. That will be part of a lecture either Wednesday or next Monday. Now, an interesting factor of computers is a computer cannot represent some floating point numbers exactly. Okay, if you have an irrational number like 1/3, you can't represent that exactly in a computer. It gets rounded off, and so sometimes you get these misleading errors. 7 divided by 3 is 2.3 ad infinitum. You should never get this 5 down here. This 5 is simply an artifact of a computer storing a floating point number in a particular way. We're not going to get into that. That's a higher level concept. So you could just ignore that right now. It's just a weirdness of an error. Now, again, like we talked about last time, y equals 7//3 print y. When we do that, remember integer division, we throw away the remainder. We just take the integer quotient, and we see that this is equal to 2. Okay, so that's the difference between floating point division and integer division. In a floating point division, you're going to get the single slash, you're going to get the decimal points. In a integer division, you're not going to get that. Okay, so we've talked about that a little bit. I just wanted to go over that again. Let's go back to the slides. Okay, so these are things. Oh, one point, just looking at a note from Professor Hamilton, the course coordinator. Let me go back to one thing then in PyChart as a note. White space. White space is a term, because it's going to come up. Means blank spaces, tabs, new lines, characters that are used for spacing your Python code. White space is ignored by the Python. Let me be careful here. White space around operators is ignored by Python. And what that means is y equals 7//3. Y equals 7//3. These are equivalent. Python looked at these two statements, the statement with the white space and the statement without the white space. This is equivalent to this because Python simply ignored all these blank spaces I've typed in here. Okay, so those are fine. You should, as a matter of good practice, include a little bit of white space. You should put blank spaces here and there in your code to make it more readable. If you start doing this too much, a human is not going to be able to read it, and you're going to have some problems. So as a matter of practice, Python doesn't care. You can run everything together. It's all cool to the interpreter, but you should just build a habit of putting white space in to make your code more readable. That's a note that I know that Professor Hamilton has asked everybody to get in the habit of. So those are the mathematical operators that we'll deal with in Python. Comparison operators, as we've said, less than or equal to, greater than or equal to, and then not equal to and is equal to. The main thing here again is that equal to is the double equal sign, and that is different from the single equal sign, which is an assignment, and we're going to talk about that a little bit later on in today's lecture about the meaning of that, so I won't get there right away. The assignment operators, the single equal sign, which we've done, and I talked a little bit about it last time. You can take a shortcut, okay? Computer scientist, guilty, I am one, we're lazy. And let's go to the end of this. Okay. Assignment statements. We can say x equals x plus 1. Okay. Let's start by saying x equals 0. Okay, x equals 0, x equals x plus 1. Not a problem. We know how to do that. Print out the value of x. X is 1. But we can be lazy, and it's perfectly good because we're computer scientists, and that's a good thing to do. X plus equals 1. When I execute that statement, x was 1. Now x is 2. X plus equals 1 is identical to x equals x plus 1. And that will work perfectly fine. It's a way of going, not counting blank spaces, 1, 2, 3, 4 characters, as opposed to 1, 2, 3, 4, 5 characters. I saved one keystroke. That's a win. Okay. We could do the same with the other standard mathematical expressions. X times equals 4. Okay, x was 2. So x times equals 4 should give me x equals 8. And when I do that, I see x equals 8. Now, addition and multiplication, you remember from your math classes, are commutative. It doesn't matter what order. X plus 1 equals 1 plus x. X times 4 equals 4 times x. It doesn't matter what order you do. Minus, subtraction, and division are not commutative. It matters. The order matters. So x minus equals 3. This is the same as x equals x minus 3. It is not the same as x equals 3 minus x. So that's important. Okay. Since subtraction is not commutative, it's important what order you do this in. And you'll see that now this is 5 because I took x minus 3, not 3 minus x. And division works the same way. X divide equals 5. Now x is 1 because this is a floating point division operator, not an integer. Not integer division. And this is 5x divided by 5, not 5 divided by x. So important to remember which order in subtraction and division. Addition, multiplication doesn't matter. Boolean operators, and, or, and not. Now, Boolean operators only deal with Boolean values. True. Okay, let's go back to PyCharm a little bit. Remember that the reserved words are capital T and capital F. Okay. A is true. This works. Suppose that instead I said this. Okay. Spoiler alert, this is going to cause an error. And the reason it's going to cause an error is Python is case sensitive, and the reserved word, the Boolean value true, has a capital T and lower RUE. Okay, that's the reserved word. This, all little characters, is not a reserved word. That is supposed to be a variable name. Python thinks that's a variable name, and it doesn't know what that variable is. And so it tells you right here, I don't know what that is. You're using a term you've never defined. This is some variable name. This is some string. Forget it. Now, when I have Booleans, okay, let's print out the value of 6 is greater than or equal to 5 plus 2. Okay? This is a Boolean expression in a print statement. This is false because 5 plus 2 is 7 and 6 is not greater than or equal to. The Boolean operators are and, or, and not. And in the slides, I have truth tables. They're pretty straightforward if you think about it. And is true if and only if something, both of its components are true. So let's say print 6 is less than 4 and let's make it true. Let's do something like this. 6 is greater than 4 and 2 is greater than 1. Okay, so let's execute that statement. That is true, because what Python does is it says 6 is greater than 4 is a Boolean. It has value either true or false. That is true. 2 is greater than 1 is a Boolean. It has value either true or false. So since this is true and this is true, the result is true. And again, case sensitive. Capital T, that is the Boolean value true, as opposed to print true equals true and false equals false. Okay, this is an interesting one. This compares the string value true to the Boolean value true. This is a string, and it's compared to the Boolean value false. This you would normally think gives you an error because this is a string compared to Boolean. Python says you're just trying to play a trick. But the value little true is not equal to the Boolean true, and this is not equal to Boolean false. So this expression is false. So the Boolean operators and, or, and not produce things that are either true or false, nothing else, unless it's an error. And there's some examples I give you. What's important is what's on the next page. These are what's called truth tables. Okay. So a truth table tells you if you have two clauses, X and Y, this is the truth table for and. If the first clause is true and the second clause is true, then the and is true. In any other case, and produces the Boolean value false, or produces true if either or both are true, and not is simply the negation. It flips the value from true to false and false to true. So these are things you can use in conditionals, which we're going to get to in a few minutes. Okay, so these are the truth tables for easy reference, and they might appear on an exam or something like that. They're fairly straightforward. This tells you when things are true. Now, we talked about order of operations in a previous example when I talked about math. Now, you know from math that you always do multiplication and division before you do addition and subtraction. And that when you do multiplication and division, you go left to right in your expression and you go left to right and you're doing addition and subtraction. Okay. And you change that by adding parentheses if you need to change that. But what happens when you're doing things that are not necessarily um, arithmetic? This table tells you how Python works. The first thing in any expression, the first thing Python does is it does exponentiation. Exponentiation always comes first. This is a slide I stole from Dr. Ben Johnson, who was the course coordinator for 201 last year. He likes videos and GIFs and things like that. And there was a meme a few years ago, if you remember it, called Honey Badger Don't Care. So Python don't care about its order of parentheses cause you to not care about order of operations. Exponentiation is first. After that, multiplication and division come next. Integer division and modulus remainder are the same as regular floating point division, so you would do any of those left to right in an expression. Then you would do addition and subtraction. Then you would do the comparisons, the less than or equal to, less than, less than or equal to, less than, greater than or equal to, not equal to, or checking to see if it is equal to. Which is why when I gave you that code in PyCharm, I did not have to put parentheses around it. When I said 6 less than 6 greater than 4 and 2 greater than 1, Python said, let's do this first. There's no parentheses, don't need them. There's no parentheses. Greater than is above and, so this got done first. That got done second. The and got done second, and then we went. So basically, this was evaluated by Python as true and true. And of course, as we said in the truth table, this yields a value of true. So that was why I did not need parentheses, because these get done before and. Not actually gets done before and gets done before or. Okay. So this is something to remember. If you're getting results you're not expecting, check your order of operations, make sure things are being done in the order you're expected to, and add in parentheses if you need to make things work correctly. This is how Python does them. So when I was doing the example in PyCharm a little minute or two ago, I didn't need to have parentheses. Okay, now, I've already given many of the coding examples, so I'm going to skip directly to conditionals now. Everything we have talked about to date is what's called a sequential or serial execution. Python executes one statement of code, then it executes the next statement of code, then it executes the following statement of code, and then it executes the next statement. So we're just doing everything serially or sequentially. Execute this, execute that, execute something else, just go straight forward. Okay. We don't always want to do that. Sometimes we only want to do or execute a line of code or a section of code if a particular condition holds. We only want to print out an error message if the user has entered a negative number. We only want to print out a congratulatory message if the student has made the dean's list. And this gets into what's called conditional control. We're going to do something if, based on a Boolean value, a Boolean variable, or a Boolean expression, something that evaluates to true or false, then we're going to decide whether to execute code. In Python, there are 3 different cases we can support. Other languages support switch statements or case statements or what have you. Python does not. Python lets us have 3 cases. One, we'll do something if a condition is true, otherwise do nothing. 2, we're going to have 2 different cases. If something is true, do one thing, otherwise do something else. And the last case is for anything more than 2 options, 3 or more. Those all come into the same thing. And we do 3 different things depending on what they have. Okay, let me check what my next slide is. Yeah. So we'll go straight to Python. You have the slides as reference or PyCharm. We'll show you how they do. Okay, the simplest conditional, the if statement. What I'm going to do is I'm going to say, if your grade point average is greater than or equal to 3.5, print, congratulations, Dean's List student. Now, I got to have some value for this to make this actually work. So let's set GPA equals 3.8. Otherwise, when I put this into my Python console, it would tell me you have an undefined variable. Okay, let's put this in here. Execute. Good. Now, let's set GPA equal to 3.0. And run the same logic. And now nothing happened at all. Okay? Nothing happened at all. We didn't print out anything. The reason was up here, the reason is we have an if statement. Sorry, I slid too far. In this case, this Boolean condition is true, so we did something. In this case, the lowercase with the 3.0, the Boolean condition was not true. We did nothing. This is the simplest case. Now, let's talk about this code and emphasize a couple of things. The syntax of an if statement is the reserved word if, and if is case sensitive. This is only, I apologize, my 2 dogs are having a little bit too much fun in the background. Hope that isn't disturbing everybody. Go play someplace else. Okay, so case sensitive, this is important. This has to be a little I and a little f. If I used a capital F, this is going to be unknown. I have a syntax error, okay? Because big I, big F do not exist. That's one thing. Case sensitive, it has to be little I, little f. Now, down here at the end, I have to have a colon. The Boolean expression is terminated by a colon. There must be a colon here. If you leave it out, you will get an error message. And trust me, this is a very common one. Let me fix my if first so I don't get that same error. If I leave this colon out, I get an invalid syntax. In this case, Python doesn't give a particularly useful error message. It's going to take me a while to figure out that what I've got here is I'm missing a colon. So you have to start with the reserved word if in lowercase. You have to terminate, you have to have a Boolean expression, and you have to terminate with a colon. If you don't have the colon, if you don't have if in lowercase, it's going to fail. You're going to have an error. Let me put my colon back. Now, do I have to have these parentheses? Would it work if I just said GPA is greater than or equal to 3.5 with a Boolean, no parentheses? The answer is it works fine. This would have been a better example had I actually printed out the statement. Let's try this again. Okay. These parentheses that I have right here are not needed. It's a matter of convention. I tend to use them. They are not required in the class coding standards. I use it to make it clear to me that this is what I intended to be my Boolean expression. They are not needed. Python doesn't care. Now, interestingly enough, though, if I have the parentheses and I don't have that white space around it, this works fine. You don't have to have the white space here because Python says, well, it's not a big deal. If is terminated by the parentheses. This is an if statement. Life is great. So you don't have to have the white space. Now, on the other hand, if I delete the parentheses here, this is going to cause a problem because Python's going to say IFGPA. I have no clue what IFGPA is. Okay. So I find using the parentheses to be convenient. They are not required. It's whatever you think makes your code understandable. I prefer both white space, blank spaces, and parentheses, but they're not. Only one of those is needed for Python to make it work. So, first, reserved word if lowercase. Second, semicolon. Third, indentation. Python cares a lot about white space. Python cares about spaces or tabs, and we'll get into that religious war in a minute. What is done if the if statement is true is everything that is indented underneath the if statement. This must be indented, okay? If I come over here and I say, let's make it 3.9, let's fix my problem, put the parentheses back in. Suppose I did not have this indented. Okay, this is going to be not a good example. I'll explain in a minute. This tells me that this is an error because you have an if statement. What's executed when the if is true is what's indented. There's nothing indented, okay? There's nothing indented here. Since there's nothing indented, there's nothing that happens after the if. And Python says, that's ridiculous. If you have an if statement, you have to have something indented underneath it. There must be at least one indented statement after the if. So I'm going to put that, since I'll be sharing this code later, there must be at least one indented statement. Otherwise, you're going to get this error in your syntax for Python. It's not going to work right. That's the point. You have to have something, that at least one thing that's indented. Now, in this case, you'll notice I indented using a tab. It works perfectly. Now we have the same code. I indented using one space. It works perfectly. Indentations can be either tabs or spaces. And if you want to start and experience computer scientists in an argument that will never end, just state which of those two you prefer. I always indent with tabs. I always indent with spaces. It is literally, and I apologize if people object to the term, but it literally almost is a religious war because you either believe in your heart of hearts that tabs are correct, or you believe that spaces are correct. There's no middle ground. I prefer, in general, to use tabs. The difference is that when you're printing this out or when you're displaying it, it depends on the display. If you use one browser to look at my code, a tab may be 4 spaces. On another one, it may be 5 spaces. Things may not line up correctly if you use tabs. If you want them to exactly show up with the same spacing, then you use spaces. I will manually type 4 spaces here. For this class, it doesn't matter. Coding standards are okay. I prefer tabs. You can prefer spaces. We'll just allow each other to disagree. And as I showed in this example, if you use spaces, the only thing that's required by Python is 1 space. But as you'll see in some of the examples later on today, 1 space makes it hard to understand. So I would say use at least 4 spaces. If you're going to use spaces to indent, 4 spaces minimum, that will make your code legible. If you're going to use tabs, whatever tabs configuration you have is fine. It's really an ugly situation. Use whatever you want. It's okay. That's the first case. Do something. If nothing else happens, you don't do anything. Now, let's change this a little bit into there are 2 cases in the conditional. So in Python, that means we have an if or an else. Now, the first case is if your GPA is greater than or equal to 3.5. If your GPA is less than 3.5, we say reserved word is else. Print close, but no cigar. Now, so let's say GPA equals 3.3. Now I'm going to run this conditional with 2 cases. Okay. And let me fix this. There we go. Okay. Now let's run that code. And since GPA was equal to 3.3, when I ran my Boolean expression, when I ran my conditional, if GPA is greater than or equal to 3.5, well, GPA is not greater than or equal to 3.5. It's 3.3. This equates to false. So this is the code that will be executed if the conditional is true. This is the code that will be executed if the condition is false. Okay, so true or false, this is true, this is false. Now, you'll notice a couple of things here I snuck in unintentionally, but now that I did it, I need to explain it. You notice here, in this case, I use double quotes. In this case, I use single quotes. In Python, when you're dealing with strings, you can use either double quotes or single quotes. It doesn't matter as long as they're the same. If you have double quote at the beginning, double quote at the end, single quote at the beginning, single quote at the end, as long as they match, it doesn't matter. Python is cool. If you get an error message, you didn't match. Okay. Another thing to point out here, with the indentation, it doesn't matter how many lines there are as long as they're indented. So let's do something else. Printed, congratulations, Dean List student. Now print You did well this semester. Now we have two statements, but they're both indented. As long as they're indented the same, this code will work. Better print. I wanted two statements anyway. Now you can see that the two statements that were indented under the else, I'm going to save this real quick. The two statements that were indented under the else both got executed. Just saving this code before I do something ridiculous and delete it. Okay. So that's two conditions, two statements. The reason that's important is I'll run this same code, but this statement is not going to be indented. Okay. Now, this case, no difference will occur, but now GPA equals 3.8. Now let's execute this code. Let's debug what happened. Okay. GPA was 3.8. If GPA is greater or equal to 3.5, that is true. When this is true, you execute this code. You do not execute that. That's a conditional. You execute these two statements. Well, it did that. There's the first print statement. There's the second print statement. But wait a minute. Why did it print that statement as well? The answer is because this is not indented. When this is not indented, it is not part of this else block. Okay, when this is not indented, it is not part of this else block. And so this will always be executed. This will always be executed if it's not indented. So indentation, white space, unlike a lot of other languages, Python is kind of strange. It cares a lot about how you indent. Okay, so all the things that are going to be executed, if it's true, indented in a block. All the things that are going to be executed, if it's false, indented in a block. If else, two conditions. Now, let's go to the last case. More than two conditions. Okay. Let's look at the coding we did last week. This is not, I give some other examples on the slides. I'll leave them on the slides. You can ask if you have any questions if they don't make sense to you. But I want to look at what we did last time. On Wednesday, when we talked about the sample coding, we started out by saying that we asked an input of an integer for what your grade was. And you had to input 4, 3, 2, or 1 for an A, B, C, or D. Okay. Now, what we're going to do is show how to input a letter grade and convert it to a number of quality points using conditionals. Okay, nothing up my sleeve. Here we go. Grade equals input, enter your grade in math. Okay, now when we do this, Now the user can enter the standard letter grade. So let's say, hey, I like math. I'm going to enter an A. Okay. Now, grade has a string that is the letter capital A. Okay. Let's convert an A to 4 points per hour. If, lowercase, grade equal, not assignment. Grade is not being assigned. We're checking to see if it's equal. 2 equals the string capital A, colon, indented, quality points equal 4. Now, I said last time that when you're doing an input statement from the keyboard, everything comes in as a string. Everything comes in as a string. When I typed an A, I got the string capital A. Well, that was great. I didn't need to cast. I didn't need to convert to some other type because I'm comparing strings. Okay? I'm comparing the string, and that's going to give me true or false. Quality points equals 4. Now, there's going to be more than one case. I have to check A, B, C, or D. So I can't use else. Well, I could use else, but that would be ugly. I could do this, else, colon, indented, if grade equals B, quality points equal 3. Okay? But that is going to be ugly when I keep going nested deeper and deeper. So Python allows me to use something called elif. Again, I get to be lazy. Okay? Elif is short for else if. Okay, so instead of saying if grade is A, do this, else if grade is B, do this, else if grade is C, do so on. Okay, instead of saying else if, I can just say elif. Elif is short for else if. I get to save a bunch of keystrokes, 3 to be specific. And now in Python, else if grade equals B, quality points equals 3. Why does it think that there's an error there? Okay. But maybe grade is C. Now, you can have as many of these and let me make sure I'm indenting. Now, notice here, this indentation is deeper than this. That turns out to be okay in Python, but I'll make it be the same, just so this is consistent, so I have good quality. And I've clearly made an error. Python is trying to tell me one. I wonder what it is. I'm going to check that in a minute. Elif grade equals D, quality points 1. Here's an error. That's a single equal sign. Okay, that's an assignment. Now, let's presume you didn't fail, but just for the illustration, else quality points equals 0. So now what we've done is we've taken a single statement and allowed you to convert the letter you input into an integer Supposedly it ran, what is the value of quality points? 4. It worked. How about that? So here is a case where we use elif. If indented code. Elif indented code. If you use elif, there has to be a Boolean here. Elif, there's a Boolean. I can have as many of these elifs as I need to cover all the cases. There has to be an else at the end. Okay, let's go back to the slides and make sure we've covered all the points that we're supposed to cover. 3 forms of conditionals. 1 option, the if statement. If it's false, the Boolean's false, do nothing. 2 options, if else. More than 2 options, I gave you one with 5. If A, elif B, elif C, elif D, or in the worst case, else. It's an F. Okay? Then you use the elif. The simplest conditional, the if statement. Do something. If student is awesome, you must be here for 201. Now you know why we spend so much time with true, false, comparison, and logical. They go after the if statement. They go after elif as well. The if and else, remember that input returns a string. In this case, in the case I showed in PyCharm, it was a single letter. In this case, it's going to be an arbitrary string that the user types in after major. Now I'm going to do something. Else. Remember the colon after the else. And do something else. Indent. If you don't indent, it's not going to work right. This is an example of what I showed in PyCharm right here. In this case, with just an if statement, the second line is not indented. Since it's not indented, it is always executed because it's not part of the if statement. The things that are part of the if statement are only the things that are indented. If you don't indent, it's not part of the conditional. It's not part of the if. Okay? There must be at least one line of code under the if statement. If you have an else statement, there must be a line of code underneath that. Let me illustrate what I mean. This is an error. Okay, x equals 6. If x is greater than 5, print x, else. Let's go up and fix that semicolon, make it a colon. There we go. Python's telling me right now this squiggly red line means there's an error. What's happening is it's not letting me execute. PyCharm's console is not letting me execute because I don't have a line under the else. If I have an else statement, I have to have at least one line of code. Otherwise, it's a syntax error, and PyCharm is going to die. Okay? Let's come down to wherever I am currently so I can get out of this silly thing. Python tells me that's an indentation error. It expected an indented line of code under the else in the block. There has to be a line of code in the else block, or else it's an error. And so Python's telling me there's an error. I expected an indented block under else. You didn't put one there. That's invalid. Similarly, if I didn't have anything under the if x is greater than 6, well, if x is greater than 6, I don't really want to do anything. So I'm just going to go else print error. And again, Python tells me there has to be an indented block. When I had else with no indentation, that's what created the error. So that's what we mean when we say in the slides that there has to be at least one line of code under the if statement. And if you don't have to have an else, you can just have, we gave the example of an if, otherwise do nothing. If you have an else statement, there has to be one line of code under it. The elif The example I give is student enter the age. If it's less than 18, hey, sorry, but you're a minor. You got a lot of restrictions on you. If you're between 18 and 21, you can do some things in this great state of Maryland, but there are other things like alcohol is above 21. If you're over 21, you're legally an adult. Now, I point out again, because this is the way the homework's worded, this is pseudocode, okay? This pseudocode says this is what you're going to do. You got to write Python that implements that. That's the pseudocode. Here is the actual Python code that implements the pseudocode. Age equals int of input. Please enter your current age in years. The user is going to type in a number, okay? But it's a string. Input always returns a string. We have to convert to an integer. We convert to integer with this int. Int of input. Take the string the user types in, convert it to an integer. If your age is less than 18, print, sorry, but you're a minor. There are a lot of things you can't do on your own. Because both of these statements are indented, they are both part of the if. They are both executed if the age is less than 18. Elif, else if, saves me the time of else if age is less than 21, blah, blah, blah. Print, you're an adult. There's still things you could do. Else, if you're over 21, print, congratulations, you're legally adult. And this code actually is missing a colon, so it produced a syntax error. Sorry about that. That was testing you. I did that on purpose. Congratulations, you're legally an adult. This is another example of the elif. Now, remember the logic flow. Here, this is really the code that gets executed. Gets executed if you are 18, 19, or 20. But notice I didn't check for that. This is the same as saying elif age is greater than or equal to 18 and age is less than 21. I didn't say that. Why didn't I say that? Because of how conditionals work in Python. If age is less than 18, this gets executed, and then I'm down here to the next line of code. This will not be executed if age is less than 18. This will not be executed. This will not be executed. So once I have satisfied one condition, I drop out, I come down here, and I execute whatever code is there. So this part, age is greater than or equal to 18, and I don't need that. It's, if you really want to put it in there, you can. It doesn't hurt, but you don't need it. You wouldn't be here if age was less than 18. If this part was false, you wouldn't be here. Therefore, you don't need it, and it's perfectly fine to leave it out because this is only going to get executed if you're 18, 19, or 20. If you're under 18, we never get here. Okay. And the last slide is homework, is coding examples. So we'll go back to those and a couple more points I need to get before we start talking about homework. Okay. So we've talked about this. I'm sorry, does someone have a question? Okay. What I wanted to say is, notice in our input statement here, we didn't say, sorry, didn't cover the whole line. We didn't say input an uppercase letter. So what happens if the user says, my grade in math was an A? Now execute my if statement. Here's where I wanted to be. What happens? Quality points is 0. I entered a lowercase a and failed the class. That's not cool. I don't want to fail the class because I entered a lowercase. You didn't tell me enter uppercase. Well, one thing you could do is prompt and say enter an uppercase letter. The other thing you can do is take into account the user may not know what to do. So let's go back to this Boolean and say if grade equals A or grade equals lowercase a. If grade equals B or grade equals lowercase b. If grade equals C or grade equals lowercase c. If grade equals D or grade equals lowercase d. This, and I'm going to find out real quick if I made any typos. This allows me more flexibility in what the user expects. Enter your grade in math. I got a lowercase b. Now, what's the value of quality points? 3. Now I checked for the correct, I allowed the user some latitude. Okay, I allowed the user to input uppercase or lowercase. Okay, and I was all right with it. So that was a point, and we could use this Boolean expression or. Again, I could have put parentheses around it to make it clearer. Operator precedence. This equals happens before the or, so I'm okay. I don't need parentheses. If I want to put parentheses there to be clearer, that's good. Okay, so that's the new material I wanted to cover tonight. That will get you all the way through homework 1 and most of the way through homework 2. Now what I want to do is go to homework 1 and talk about it and give you all a chance to ask any questions or let me know how we're doing. And if you want me to get to homework 2, I will do that as well. This should be homework 1. Okay, so here we are. Again, you're due midnight Wednesday night, so you've still got time. The major section's got an extension, and they got an extension till tonight, so they're still working on it. Okay, walking through this. Input validation. Now, this is a note about what I just showed. Okay, as we get more into the semester, as you get more and more on your homework and you get better at programming in Python, we will ask you to check to see that the user entered a meaningful value versus a meaningless value. In homework 1, you do not have to do that. If you want to do that, that's cool. If you want to validate input, that's cool. You do not have to. So we ask the user to enter a number. If the user doesn't enter a number, but instead enters a string, 20, okay, your program will fail. Literally, if the user enters a string instead of a number, your program will fail. You know what? For homework 1, that's okay. Don't worry about all the foolish things a user will do to mess your program up. It's okay. Okay, so when we say input validation, don't worry about checking to see that the user entered, a number. It's okay. When we grade the homework, we're not gonna do something stupid like that. So it's okay if your program crashes. For now, later on in the semester, we will test that, and you will have to pass. Okay. So question 1. We give you pseudocode. You know what pseudocode is? It's an English description. Write the program. Create a variable called numDogs. Creating a variable just says use a variable name and assign it some meaningful value. It says to initialize it. So you have some variable, numDogs, set it to 0 to start with, you're cool. Set a variable called numCats, set it to 0 to start with, you're cool. Set a variable named numFish, set it to 0 to start with, you're cool. You could set it to -1 to check later on if you want, doesn't matter, set it to 0 is fine. Now, create a variable named favorite restaurant and set it to be the name of your favorite restaurant, whatever. You're graded on whether it exists and it's a string. That's all it is. Okay, set favorite restaurant equal to McDonald's, White Oak Tavern. Chef Paolino's. I don't care. You tell me what your favorite restaurant is. Just have a variable favorite restaurant, single equal sign, assignment statement, single equals, and then a string with the name of your favorite restaurant, Mom's Kitchen. Cool. Okay. Create a variable golden ratio and set it to be the golden ratio to 3 decimal points. Don't just use the integer 1. Look it up. If you don't know what the golden ratio is, Google it real quick and set it to 3 decimal places. If you want it to be more than 3 decimal places, you can make it more than 3. That's fine. You just have to enter 3. Now, using those variables, here's a print statement. Print the variable favorite restaurant with a meaningful string that says, this is the name of my favorite restaurant. Print statement. Second, print out your approximation. That is, whatever value you entered for golden ratio, just print it out. We're not going to grade you in this assignment on how many decimal points you print. If it prints more than 3 decimals, that's fine. It doesn't matter. Print out the number of dogs and cats and fish. What that is print num dogs, print num cats, print num fish after assigning them the values that you actually have. Okay. The last thing, add them up. Print out the sum of pets you own. Add num dogs plus num cats plus num fish. That's all you have to do, and print out that sum. Here, we're just saying, whatever meaningful text, don't just print out the variable. If you say favorite restaurant, then we don't know what that is. Yeah, it'd be some point off, but make it look something like this. That's number 1. Okay, question 2, very similar. Ask the user for a Pokemon name. That's an input statement. Pokemon name, or whatever your variable is called, equals input, quote, please enter a name of a Pokemon. Ask the user for a Pokemon type. Input statement. Pokemon type equals input, quote, ask, please enter a Pokemon type. Whatever. Print out a sentence. We haven't really covered this. This is a good thing for me to say. When we combine 3 strings, it just concatenates them together. Okay, this is a good thing. Let me go to PyCharm real quick and illustrate. This is why I wanted to go over it. String concatenation. When you have 2 strings and you use the plus sign, that adds them together one after the other. New Orleans plus Saints. I have 2 strings. I tend to use double quotes most of the time. You'll notice that. You don't have to. Singles or doubles are good. New Orleans plus Saints. This is a string. This is a plus sign. This is a string. It concatenates them together. Now, concatenates says add them together. It did not insert a blank space there. It just took this string and it put this string right on the end of it. Okay, if I wanted a blank space there, then I needed to insert a blank space in the string. Or I could have done this, and I can concatenate multiple things together. A blank space. Here, I'm concatenating 3 strings together. I'm concatenating this string, I'm concatenating this string, and I'm concatenating this string, and I'm going to call that a sentence. And now when I say what's the value of sentence, you can see it's added the 3 strings together. So this is why I go through this, to make sure I've covered all these things. So print out a sentence which combines the 3 pieces together. This was a variable called Pokemon name. This is a variable called Pokemon type. This is a variable called Pokemon move. You're going to create the sentence by saying Pokemon name plus Pokemon type plus Pokemon move. That's what we mean by print out a sentence. Concatenate those 3 strings together. Okay? When we say we're not going to tell you what the variables are called, you have to pick a name, meaningful Pokemon name or something like that. Doesn't have to be Pokemon name, but something meaningful like this. And then, as I said, concatenate the 3 strings together and it produces this sentence. Question 3. Ask the user for a type of animal and put in the variable pet type. Pet type equals input. Give me the name of an animal. Ask the user how much they spend on food per month and store it in monthly food. Monthly food equals, you probably want this to be a float because this is probably dollars and cents. Float of input, how much do you spend on food per month? How much do you spend on other supplies? Input statement, convert to a float. Add these two variables together. Aha, that's why we converted to float. Okay, add these two together and then multiply by 12. Hey, we can do floating point arithmetic and store it in annual cost and use the variables to print out the annual cost of owning an animal name, and whatever variable here is annual cost. To illustrate that, okay, dog, how much you spend per month on food, convert that to a floating point. How much you spend on other supplies, convert that to a floating point. The annual cost, in this case, it's an integer. It comes out as a whole number. So I guess if the user's only going to input integers, you can make this integer, but be ready for it to be a floating point. Okay. That's part 3. Part 4. Translate this pseudocode into a Python program. Here it is. You're working as a car salesman. You make a commission, gross profit. Okay, write a program that calculates your commission amount given the car price and the gross profit. Okay. Input statement. Ask the user to input the car price, calculate the commission. Multiply the car price by, sorry, going the wrong way here. Multiply the car price by 0.05. 5% is 0.05. Print that out. Now we get into the physics. Part 5. Translate this pseudocode into a Python program. Do not, energy is a mass, m at velocity v according to this equation. Do not worry about squaring. Squaring is just what? To the power 2. So take the value and exponentiate it to the second power. So in other words, if you want c squared, it's c star star 2. If you want v squared, that's v star star 2. If you want c squared again, you've got that. It's c star star 2. Now, what about the square root? Yes, Python has a square root function built in. Don't worry about it. We don't need it. What is the square root? It's something to the 1/2 power. Okay, you should have learned this from math already. The square root of something is just that to the 1/2 power. So how do you calculate the square root? You take this quantity, raise it to the 1/2 power, and you're done. Okay. Will square root work? Yes, but we haven't really covered it, so make sure that it's installed. The answer is square root is part of a math package. So if you have the math package installed with Python by default, it'll work. If you don't, it won't. Let's go look at PyCharm and see. Let's just print out square root of 49. We all know the square root of 49 is 7. And in this case, I do not have the math package loaded with my Python interpreter, so square root is undefined. So that's why we say raise it to the 1/2 power, because that will always work. Square root only works if you have the math package already loaded. We will be guaranteeing that math is loaded later on in the semester, but for now it may not be. So that's why you raise it to the 1/2 power. Okay. Like I said, if you installed the math package and square root worked, we're going to let it slide for now, but you understand that it's a separate thing. So in 6, it's the same thing. G times M1 times M2 divided by D star star 2. A lot of people who are not physics majors, I understand that. I have a degree in physics, but understand that it can be strange. Do not worry about meters cubed over kilograms times seconds squared. We do not use units in this program. In question 6, you do not have to use units. Okay, so don't worry about raising meters to the third power or seconds to the second power. Those are just units. You don't have to worry about them. What you care about is this number, 6.674 times 10 to the minus 11. Okay, everything else is going to be presumed to be in kilograms. You don't have to convert. Okay, when the user inputs a mass for object one, the user inputs it in terms of kilograms, not pounds. You don't have to convert. Don't worry about it. Okay, it's fairly straightforward. It's just plugging in. Okay, and here in good coding examples, you ask the user to input in kilograms. Again, if the user inputs something else that's not a number or whatever, your program fails, that's cool. It's okay in homework one. So that is what homework one. When you submit, it's like submitting your previous homeworks. You should submit 6 separate files. You are going to submit 6 separate files with homework one on GL. Okay, we talked last time, if you want to do all your work on PyCharm and then SCP, or if you're on a Mac, just SCP it over to GL when you're done, that's fine. That's cool. If you want to do it in Emacs on GL, that's great too. Either one will fine. You have it on GL. When you're ready to submit, this is the command. Lowercase, you're on GL, you're in the directory with all the files, submit, CMSC 201. This is important, uppercase HW1. It has to be uppercase HW1. If you use lowercase HW1, it will fail. You'll get an error message. And then you list all 6 of the files. It should confirm that all 6 are submitted. Now, what do you do if you've only got 4 of the 6 done? Remember, in 201, you can submit multiple times and only the last will be graded. Please do not wait until midnight Wednesday night to try to submit everything at once. If you've got 4 of the 6 done already, submit the 4 you got, and you can resubmit later with all 6, and that's okay. Okay, I see by looking at my watch, I've been long-winded again. That is all for class today. If you have any questions for homework one, go to office hours. You can do them on Discord. You can ping me. We'll get it done. Get it done as quickly as you can. You can ask questions on Wednesday as well. On Wednesday, we will talk about homework 2. Homework 2 is out there. It is due next Monday. It is due the 21st of September. For the majors, it's due the 18th. Ignore that. They have to do it on the 18th. For you, it is due the 21st. You have through Monday. So we can talk about homework 2 both on Wednesday's class and next Monday's class if necessary, but try to get that started. With that, I'll go ahead and stop recording. Thank you all, and I will talk to you the next time.